friends, and welcome back. Now that we have looked at measuring the bicycle level of service using the highway capacity manual 2000 method, in this lecture we are going to introduce you to another form of measuring the bicycle level of service, that is using bicycle compatibility index. So, what we are going to tell you is in this lecture is what is bicycle compatibility index, how it is used for developing bicycle level of service, and how it is different from, you will then see how it is different from the highway capacity manual for developing bicycle level of service. What the bicycle capacity compatibility index allows you to do is, it allows you to measure the bicycle operational evaluation, design evaluation, as also planning. So, it can be used at 3 different phases of evaluating your bicycle facilities on the on your urban streets. It gives you an operational evaluation for existing roadways and can be evaluated to determine how the bicycle level of service is present. Designers, on the other hand, designers can assess new roadways or roadways which are being redesigned or retrofitted to determine if they are bicycle compatible. And for planning stages, the model provides the users with a mechanism to quantitatively define and assess long range bicycle transportation plans, right. So, this bicycle compatibility index can be used for different times or different phases of development of bicycle facilities. In the highway capacity manual method of determining BLOS, we looked at that if they must be existing bicycle facilities for which level of service can be determined using that method, but BCI allows you to do it for different phases of development. What it tells, what essentially BCI is, it is an index. So, bicycle compatibility index reflects the comfort level of bicyclists on the basis of observed geometry, surrounding land use and operational characteristics. So, there are 3 different things that the compatibility index looks at. It looks at the geometric considerations, the surrounding land use and also the operational characteristics of the roadway. So, in a sense it is taking a little bit of a holistic picture of what a bicyclist may encounter while he or she is riding a bicycle on the roadway, right. So, these are not for dedicated shared use dedicated bicycle paths or shared use bicycle lanes which pedestrians can also use. So, these are purely for bicycle lanes that are on the streets, right, that are sharing the right of way with the other motorists on the road. What it says is that if the bicycle, the calculated index, if the bicycle BCI index or BCI index value is low, the greater will be the comfort level. So, the greater is the comfort level, the better is the level of service. So, you see as the bicycle index reduces, right, reduces from 5.3 to 1.5, the level of service improves and the compatibility level also improves. So, this is what essentially we mean by bicycle compatibility index. So, what essentially it is a relationship between the index develops a relationship between different characteristics of the traffic and the area that a pedestrian may face, right. So, it is a linear simple linear regression linear multiple regression equation, or the model is a linear multiple regression model that gives you this compatibility index, which in turn determines how well the comfort level of the bicyclist is when he or she is riding the bicycle on the roadway, on the pavement or on the street shared with other types of motorized vehicles. So, if you start looking at each and every term of this, you will see that the first term that the compatibility index depends upon is the presence of a bicycle lane or paved shoulder. If there is a presence of a bicycle lane, or also if the road has a paved shoulder which is greater than 0.9 meter in width, then the bicycle compatibility index depends upon this factor called BL. The next factor that it depends upon is what is called BLW. Now, BLW is the bicycle lane or the paved shoulder width, right. So, the first variable is a yes or no kind of a variable. Is there a paved shoulder greater than 0.9 meter, or is there a bicycle lane? If the answer is yes, then that will have a value of 1. If the answer is no, then it will have a value of 0. So, it is a yes no kind of a variable, dichotomous variable, whereas BLW is actually the width of the paved shoulder or the bicycle lane. So, if only this is 1, this can have some value. If this is 0, this cannot have any value, right. The next thing, the next variable is what is called CLW. Now, CLW is the curb lane width, right. So, what is the curb lane? A vehicle, the vehicular traffic lane that is closest to the curb, right, because the cyclist will usually bicycle very close to the curb. So, the lane that is next to the bicyclists and closest to the curb is called the curb lane, and the width of that curb lane is what plays an important role in impacting the compatibility index. The next one is the curb lane volume. So, width of that lane and what is the volume of traffic on that curb lane. Next is other lane volume, all other lanes in the same direction, right. So, there may be 2 lane in one direction and 2 lane in the other direction. Out of the 2 lanes, the first innermost lane would be the outermost lane would be the curb lane, and the other inner lane will be the other lane. So, the volume of traffic on that other lane is what we are worried about, and we will not be worried about the volume of the traffic in the opposing direction. The next thing is speed. So, the presence is again the 85th percentile speed of traffic. Remember how to determine 85th percentile speed, we have already told you. The next variable is PKG, or the presence of a parking lane with more than 30% occupancy. So, if there is a parking lane, again it is usually right next to the curb where the bicyclists usually bicycle, right, where you will see very few people, very few bicyclists trying to bicycle in the middle of the road. They would rather bicycle on the side of the road, which is alongside the curb. So, if there is presence of parking in that in that segment, and that parking lane is more 30% or more occupied, or occupied meaning there are more than 30% of the spaces that are filled with parked vehicles, then the variable is called the variable PKG will be 1, otherwise it will be 0. Again, this is a 0 1 type of a dichotomous variable, presence of parking lane, yes, no. So, that is kind of a answer for that. The next variable is area, which is type of roadside development. If it is residential, then the value is 1, if it is others, it is 0. So, there has been it has been noticed that the bicyclists, the comfort of bicyclists depends upon the area. If it is a residential area, they feel more comfortable versus bicycling in non-residential areas. So, it has been only for simplicity's sake, it has been only divided up into 2 such areas, right. And the last thing is there are about 3 different adjustment factors that have to be taken into account, and we will see what those adjustment factors are. They are usually right turning adjustment factors. If you bicycles that is turning right, because this is developed in the US, it is right. For our case, it will be left turning vehicles adjustment factor, parking adjustment factor, and I think heavy trucks, if there is heavy vehicles moving on the road. So, they have to have a adjustment factor for that as well. So, you see when we were talking about highway capacity manual method of determining level of service of bicycles of dedicated bicycle lanes, they were dependent upon the number of events, right. They were dependent upon how many events, passing events or opposing events that a bicyclist meet, whereas when we are talking about bicycle compatibility index, it depends upon a larger number of factors, because these are bicyclists that are on the right of way, that are riding their bicycles on the pavement sharing with other motorized vehicles. So, it takes into consideration a whole lot of factors in order to determine this compatibility index. So, we have looked at all of these factors one by one. You have to also then look at their signs in order to understand their impact on BCI, right. So, if it is a negative sign, meaning the bicycle compatibility index is going to decrease by the presence or absence of a bicycle lane. So, if it goes from 1 to 0, that means if there are no bicycle lanes, so this is a reduction. So, and then the bicycle compatibility index is negative sign. So, it will go up. Remember, if bicycle compatibility index goes up, the bicycle level of service or the comfort level usually goes down. So, not only do you have to determine, you have to understand the sign with the compatibility index, but you have to also understand the compatible index's relationship to level of service. Okay. So, you have to understand both of those relationships when you are looking at the compatibility index and this linear regression equation. So, here are some pictures which allows you to understand what are all the different types of different terminologies that we were looking at. So, when we are talking about curb lane width, right. So, if there is a curb only here and the curb it is about, you take about a 0.3 meter shy distance, because bicyclists will not hug the curb very closely. So, when you are determining the curb lane width, it will be that width from the center line to about 0.3 meters away from the curb. When there is a curb and a gutter, then you can just determine the curb lane width from the end of the gutter line to the lane. So, again see, this is a 2-lane road, 2 lanes going this way and 2 lanes going the other way. So, we only are worried about when we are determining the bicycle level of service for this direction, for the up direction, we are not worried about the volume of traffic in the other direction. We are only worried about the volume of direction in the curb lane, which is this, and if you are talking about the other lanes, it will be only the other lane present there. When we are also want to determine in the presence of a bicycle lane, if there is a bicycle lane present, then when we are determining the curb lane width, so the curb lane width would be width from the bicycle lane to the lane demarcation here. If there is a curb only curb present, again the width of the bicycle lane or the paved shoulder should be 0.3 meters, should be incorporating the 0.3 meter shy distance from the curb, right. Similarly, when both curb and gutter are present, it is just from the gutters line to the paved shoulder or the bicycle lane. So, that will give you the width. Now, when determining parking, if there is parking and you want to determine the curb lane width, so it is assumed if it is not marked, right, if the parking lane is not marked, but parking is allowed along the curb, then you say that the assumed parking lane width is 2.4 meter wide. So, you leave 2.4 meters and then you determine the curb lane width as to be that much, whereas if it is marked, then you already know where parking is available and the rest of it is the curb lane width. Curb lane width is the most essential, because the width and the volume of vehicles on that curb lane impacts the comfort levels of the bicyclist in a greater degree, as opposed to if there is another lane in the same direction, the volume of the vehicles on that lane does not usually affect, because most of the bicycles usually ride along the curb and not too much along the middle of the road or the outer vehicular lane. Similarly, if you have to determine curb lane width when both bicycle lane and parking are present, the dimensions are shown here once again. How do you determine the speed? we have already told you in the previous lectures, 85th percentile speed is nothing but the vehicle count and the vehicles 85% of the vehicles or the speed at above which the only 15% of the vehicles are traveling, that is called the 85th percentile speed, and that can be calculated in the field just by developing a cumulative distribution ogive. If you do not have data available, you usually assume that the speed on the vehicular speed is 15 kilometers per hour higher than the posted speed limit, because usually the posted speed limits are on the conservative side and people drive at a higher speed than what is posted for that road. So, now how do you determine the curb lane volume and the other lane volumes, right? You know the curb lane width that impacts the bicycle compatibility index, and you also have to calculate the other lane volume which impacts the bicycle compatibility index. So, how do you measure them? AADT, if you have AADT, that has to be converted into hourly traffic volume. AADT is annual average daily traffic collected continuously for 24-hour period. This is the best source for traffic volume information, not the only source, but sometimes it is the only source, but it is usually the best source of understanding what the traffic volume on that road is. So, once you have the AADT, you can convert it to peak hour volumes by using some a K factor or conversion factor that allows you to convert the proportion of vehicles traveling during the peak hour. Okay. You always are worried about peak hour traffic, and that is the traffic volume for which you usually design facilities or you measure any measures of effectiveness. So, if you know the AADT, you multiply that with the peak hour factor and the directional split. Again, directional split is the standard values are given here 0.1 and 0.55, but it may be different for your street, and you can calculate that. Once you know the peak hour volume, you can then use the peak hour volume to calculate the curb lane volume by dividing it with the number of lanes, simplistically dividing it with the number of lanes in that direction. And if you have if you have only 2 lanes, then the rest of the volume is going in the other lane, where if you have more than 2 lanes, then you can just sum up the other volumes to be in the other 2 lanes. You do not have to know individually what is the volume of traffic in the other lanes if the lanes are more than 2, right. So, you calculate those, and once you know that, you can develop the compatibility index. So, what happens is once you know the compatibility index of each of these streets, then you can develop a map for your city or your region, highlighting the streets that are highly extremely compatible for bicyclists, and whereas the ones that have low compatible index. This allows you to allows your bicyclists and gives them an idea of where to bicycle based on their own comfort levels, right. This is for an average bicyclist we are talking about. There may be bicyclists who are very young versus there are bicyclists who are very professionally good at bicycling. So, their compatibility index may be different, but this is for an overall average bicyclists. This also allows you to understand where the weak links are, how you can improve the compatibility index or the comfort level for an average bicyclist and work in that direction. So, this is a very handy tool for your urban local bodies or your public works department in order to improve whenever they are either improving the travel lanes and they wanted to put in a bicycle lane, they can easily assess how the compatibility index will improve. So, if you were to solve a problem, you can see that shown in these 2 pictures are multi-lane, 2 lanes in each direction, wide curb lane arterial that serves commuting bicycle corridor, right. It serves both the commuters and the commuting bicycle corridor. The curb lane width is measured from the center of the lane line to the gutter pan seam and is 4.3 meters. The AADT is 15,000 vehicles. Speed limit posted is this. And a study shows that the 85th percentile speed is, however, 75 kilometers per hour. As indicated, there is no on-street parking, and the development along the roadside primarily consists of retail and commercial businesses. Right? They are mostly retail and commercial businesses. There are no residential. And consider that the adjustment factors are nil. So, there are no heavy vehicles or no parking and no right turn or left turning lanes. So, there are no adjustment factors available. How do you calculate the bicycle compatibility index and eventually the level of service? So, you are already given all of these factors. First thing to find out would be to the curb lane volume and the other lane volumes. So, you already have the AADT, you have standard values of K and D. So, you know the peak hour volume, you know it is a 2 lane road. So, you divide the peak hour volume by 2, you get approximately the curb lane width, and the other half is the other lane width. So, you know now you have calculated both of them. You know that there is no paved shoulder. So, BL is 0, BL is 0, automatically there is no width. Curb lane width is given, speed is given, or the 85th percentile speed is given, no parking, and the area is 0 because it is not residential, it is more commercial and retail, and there are no adjustment factors. So, you plug in all these values in the BCI model or the BCI equation, and what you get is a BCI value of 4.22 or approximately 4.3. And if you go back to your standard table, you will see that 4.3 falls in the BLOS at the level of service of D. So, then you can now say that for an average bicyclist who is bicycling on this road, for them the compatibility index is very poor or moderately low. So, number of other steps have to be taken, and if people ask you what steps you might have to take, then you can easily tell them that based on these equations you have to possibly maybe put in a bicycle lane there, demarcate a bicycle lane of a certain width. So, that will help in improving the compatibility index or increasing the compatibility index, lowering the compatibility index or improving the bicycle level of service. So, these factors will allow you or allow the urban local bodies to know on which improvement measure they have to bring in order to impact the BCI and furthermore the BLOS. So, that is how you have to use your bicycle level of service. So, hopefully, you have now got an overview and understanding of how bicycle level of service and compatibility index can be calculated. As we have already told you, this is a very new phenomenon in India, and we are yet to develop our own measures, but giving you an idea about this, about the international best practices, helps you take it forward and developing a India specific bicycle level of service. In conclusion, what we have looked at is what is BCI, what are the factors on which BCI depends upon, and we have also understood that a higher BCI score means a lower BLOS value. So, that is something that is important to remember. Thank you.